So in this video cast, we'll finish up with buffers, and we'll look at chemistry in your life and look at how biological systems are really super sensitive to pH. You happen to be a biological system, and humans have a system that is called the circulatory system, which consists of blood. And blood usually has a pH that's just slightly basic, and it's about between 7.3 and 7.45 at human temperature, which is about 37 degrees Celsius. And so that changes our K just a little bit as well. But suffice it to know that you have to stay within that range, and if you fall below 6.8 or above 7.8, that's super bad. That means that your body system is going to be either in superacidosis or superalkalosis, and you usually can't survive that much of a change. And so wide swings in pH are not good for a biological system like you. So commonly we experience acidosis in physical activity, and what we do to regulate this production of H+, or this acid that's produced from lactic acid and other sources, the body has buffer systems in it. And the major buffer system that works in the blood area, the circulatory system, is the bicarbonate carbonic acid system. And so these two ions exist in your blood, and normal blood plasma contains about 20 times as much of the base HCO3- as the acid H2CO3. I think this is produced because humans produce H+ quite a bit when they do physical or some type of activity that causes you to have lactic acid produced, or physical activity that causes acidosis. And so let's take a look at this from Henderson-Hasselbalch equation. And the pH is equal to the pKa plus the log of base over acid. And normally you want to be around a pH between 7.3 and 7.4. And so the pKa of H2CO3 we could look up. And then we notice that the base is almost always 20 times more than the acid. And this is in normal blood plasma. And the concentrations generally of that HCO3- is about 0.024 molar, and the concentration of the carbonic acid inside blood plasma is about 0.0012. So you can see this is significantly more, about 20 times more than this. This is high capacity, and it's made to buffer lots of H+. And so the equilibrium equation for this ends up being H+, which is produced by your physical activity, being buffered by the base portion, HCO3-, and then this produces some H2CO3, which of course is the conjugate acid. And H2CO3 is a special type of acid, though, because it immediately decomposes into water and carbon dioxide gas. And so if you have lots of acid being produced, then the buffer system makes more of this H2CO3, making more water and carbon dioxide gas. And of course you exhale this CO2 gas when you're exercising. And so if you do lots of exercise or very stressful exercise, that's what's causing this exhaling of CO2 gas, is you're producing it by buffering the acid that your body is producing. So you're stressing the system by eliminating CO2. And if you remember, Le Chatelier's principle said that if you remove something from a system, like CO2, and you have less of this, the reaction will shift to the right. And so this entire system will shift to the right. You'll use up more of this buffer. You'll also use up the acid, which you want to do to remain that 7.4 pH in your system. It removes the pH H+ ion, or lowers the acidity in your system. And so one of the tricks that a lot of people ask about is, how can I tolerate more of this acid? Because then I could run faster, I could move and do more things in a quicker system. And so some people have used this bicarbonate as a supplement. You may have heard of sodium bicarbonate supplementing, or taking some baking soda as a supplement. But more importantly, the best way to handle this is to train this system to be able to handle more. And it actually is trained to more efficiently or quickly remove or move this H plus out of your body systems, and then it becomes more efficient. And so bottom line, training is the thing that's going to make your body more able to remove this acidosis from the system and make you work harder for a longer amount of time when you're doing your activity. So hopefully from this buffer everyday life activity or small chat, you learned a couple of things. You learned that buffers are made of a system of a weak acid and a conjugate base, and that you learned that the body system has about 20 times as much basic buffer system, and that you learned that if you shift the system to the right by adding more H plus, you expel more CO2, and that is what causes you to be in equilibria and not go too acidic or too basic in your human pH.